It's up on the screen. Oh, nope, that's not it. There it is. There it is.
I'm going to put your first one.
All right, so this is, let's see, fifth hour. Let's look at our fifth hour Algebra 2. Let's go to the grade screen. Oh, this student hadn't turned their stuff in. This is my fake student. I'll go make sure my fake student turns his stuff in, but he hadn't turned his stuff in. So fake student has not submitted anything. This week we have solving systems of nonlinear equations along with graphing systems nonlinear. Those go together real nicely. Next week, you see, we have our first test. So systems of equations, systems of nonlinear equations, and then we'll have our test next week. So if you still haven't done last week, you need to get that done. If you didn't do well, go back, see if you can improve that. If you need some help with that, that's what Thursday and Friday will be for. And this week. So be sure you're understanding before we get to next week's exam on that. So let's look at 1.03 and 1.04 this morning. Activities. There we go. Activities. All right. Solving systems of non-linear equations. It's coming. There we go. All right. Let's look at what the little story is starting off here. The space probe Deep Impact was launched on January 12, 2005. The mission of Deep Impact was to fly as close as possible to the comet 9P/Temple and investigate the interior composition. We want to know what it's made of, right? So NASA's rocket scientists just pick a random spot in the sky to launch the probe? No, it took careful planning and use of systems of equations to align the trajectories of both objects so they would meet. You got to figure out what is the path of the comet, what is the path of the rocket, and we want those to find a meeting point where the rocket can get to the comet. But wait, comets don't fly in straight lines, they curve. That's correct. Systems of equations have only used linear equations so far, so how's this possible? So great question. System of equation doesn't apply to just linear equations. We can do systems of equations with curved lines. So this lesson is going to focus on solving systems of equations when they're not straight linear lines here. All right, we have one essential question. How can elimination and substitution adapt to solve a system with non-linear equations? So when solving quadratics, one of the most important tools is the discriminant. That's part of the quadratic formula. When we click discriminant, it'll give us more information. Thanks, Jonathan. This is a trinomial, ax squared plus bx plus c. That'd be a quadratic because that's x squared. The discriminant is the b squared minus 4ac. That is, when you do the quadratic formula, that's the part that's underneath the radical, the square root of b squared minus 4ac. And this is what it tells us, that b squared minus 4ac, using the b, a, and c in the equation. Oh. Oh, we have a fire drill. Okay, we're going to take a 10-minute break because we have to go leave the building and save ourselves. So we're going to take a 10-minute break and we'll reconvene here about 12 minutes after. Let's try that. All right, I survived. I'm back. Woohoo! Got a little breakfast break there if you hadn't had breakfast yet. Anyway, let's get back into our discriminant here from our fire drill being over. So anyway, if you calculate that b squared minus 4ac and it equals 0, there's going to be one solution to that quadratic equation. One. That means one solution. That means it's going to cross the x-axis one time. If it's a positive perfect square, there'll be two rational solutions, which means there'll be whole number solutions. Might be 2 and -2 or 5 and -1, you know. If it's a positive number, but not a perfect square, maybe it's 7, you'll have two irrational solutions, like the square root of 7 or something, you know. two irrational solutions. And if it's a negative number, then that means there's two imaginary solutions, complex numbers, right? Imaginary solutions. So that discriminant can help you know how many solutions there are in a quadratic. So, all right, let's talk about factoring. So we're all about solving this quadratic factoring. Let's move on, and we'll come back to that because I want to look at the systems part. They're doing solving quadratics, which is really a different lesson. So this is giving us completing the square quadratic formula grouping. It's all ways to solve a quadratic equation, but this is about systems of equation. So you can look back on this one, how to solve that, but let's go on to the systems. So the first equation they gave us here is a quadratic equation. It has an x squared, right? So the highest exponent is 2. It's a quadratic equation. The second one's linear. X plus y equals -2. That's just a line. That's y equals -x minus 2. So how do we solve that using the substitution method? All right, so let me write that down because we're going to do that. Y equals x squared minus 5x plus 1. And our second equation is x plus y equals -2. Now let's see which way they substitute it, because we'll do it the same way. Oh, they have a video for us when they did it. So they're going to substitute x plus y equals -2. See which way they're substituting.
All right, Maddie or William?
Okay, I see the way they're substituting. We'll substitute the same way so it's not confusing if you go back and watch the video. All right, so what we have is two equations. One's linear. Oh, let me put it up on the screen. Whoop. One's linear. One's a quadratic. Now, here's the thing we know. We know that y equals. That's what y equals. It equals this equation. So we can take that and substitute it in the second equation for y. So we have x plus this. X squared minus 5x plus 1 equals -2. All right, see what we did? We took what y was. This is what y equaled, so we substituted it into that equation for y. Now let's just solve this for x. So we have an x and a -5x. Those can be combined. So let's put the x squared up front. X minus 5x minus 4x plus 1 equals -2. Let's move the 2 over here. So let's make this a plus 3 equals 0. So that's why it was showing the different ways to solve a quadratic equation, because we got to solve this now. So fortunately, this one factors. This is a factor. If you go back to your factoring quadratics from earlier in algebra, x minus 3 and x minus 1. Oh, that doesn't factor. Wait, that doesn't work. Yeah, it does. Yeah, it does. Because -3 times -1 is +3. -3 plus -1 is -4x. So that is the factors that would equal that equation. So in this case, x minus 3 is one of the solutions when that's 0, or x minus 1 is one of the solutions when that's 0. Because if we multiply these two together and we get 0, that means one of those has to be 0. Because you have to multiply by 0 to get a 0. If this was a 2 and this is a 5, there's no way it would be 0. 2 and a 0 would be, or 0 and a 5 would be. So one of these has to be a 0. So either one would make that true. So x equals 3 or x equals 1. That's two different solutions in there. Now to get the y, we've got to substitute it back into here. Let's take the 3 and say 3 plus y equals -2. Subtract 3.
You can absolutely use
y equals -5.
Absolutely, I love that.
So one of the solutions is 3, -5. Because when x equals 3, the y equals -5. The other solution, 1 plus y equals -2. Subtract 1, y equals -3. So when the x is 1, the y is -3. So these are the two solutions of this systems of equation, where one's linear and one's not linear. Let's take a look at that. If we graph that, what does that look like? So I'm going to go to the graphing calculator. All right, first of all, let's verify that we factored correctly. X squared minus 4x plus 3. That was our original quadratic equation. See, there's the graph of it. Now, if we put in the factors, x minus 3, x minus 1, that's what we factored that to. Look, it's the same line. If we turn off the red line, see, the red line and the black line are the same equation because they make the exact same graph. So that's always a way to check yourself. If you have a quadratic equation and you factor it and you're not sure your factors are correct, graph them both. Graph the original and the factored version, and it should be the exact same graph. If it's not, then your factoring was not correct. Good way to know that. So, all right, so that is the proper factors. Let's put in the x plus y equals -2. Plus y equals -2. All right. Why did not? Oh, I didn't put in the original. I didn't put in the original equation. This was minus x squared minus. That was after I did it. X squared minus 5x. I got to put in the original equation. I checked my factoring, but the original equation is x squared minus 5x plus 1. Let me show you that on there. I'm solving this system's equation. X squared minus 5x plus 1 and x plus y. So that's the two equations I have to put in to check these answers. I put in these two equations to check my factoring. All right, so I graph that, and those were the same. So my factoring was good. I can move on. But checking our answer for these two, it says the answer is 3, -5, and 1, -3. Well, let's see. Here's one of the places where they cross. Oh, look, it's a 1, -3. 1, -3. If I graph that point right there. And the other one we said was 3, -5. 3, -5. Label that. That is the solutions. Remember when we were doing linear equation, the solution was where the two graphs met. Where was the point that they meet? Well, with this case, there's 2 points where they meet. So those are both solutions. Both of those are solutions to this system of equations, because that's where they're equal to each other. When x is 1 and y is -3, both of these equations are exactly the same. When you put x equals 1 into this quadratic, the y will be -3. When you put x equals 1 into this linear, the y will be -3. They are the exact same thing. And same thing with 3, -5. Two solutions.
So you're predicting.
All right.
Take a guess.
So they do the same thing here. Let's see. Let's go to the end of the video. Spoiler alert. X equals 1, y is -3.
I'm not asking.
X equals 3, -5. They got the same thing. Also shows the elimination method. If you remember, we did substitution and elimination. Here's 8 steps to do that. Depending on the equation, sometimes linear takes more steps. So you can go through there if you want to see the elimination method, because it's when you don't have two linear equations, that can be trickier. So we're not going to go through the elimination method, but know it is there. If you want to look at it and compare it, you can compare it to the substitution method. Let's look at the next problems. All right, this one says solve the system using substitution or elimination. It's 2 steps with substitution, it's 3 with elimination. But here it is, y equals, here, let me write this down. Y equals x squared minus 8x plus 12.
Okay. So you could use.
And then y equals -2x. Okay, so substitution, both of these are y equals. So we can either substitute this into that equation or that into this equation. Let's see which one they did. They substitute the y for the smaller one. So let's do that in ours.
Yeah.
All right. So since y equals this, we'll take y out of the other equation. and put this in for it. So we're going to put that in for that y. So negative 2x equals x squared minus 8x plus 12. Okay, let's solve this for x. Let's add 2x to both sides. 0 equals x squared minus 6x plus 12. Okay, so now we need to factor this or complete the square or use the quadratic formula, whichever we like it. So is there a solution using factoring? 12 would be 1 times 12. 1 and 12 not equals negative 6. It could be 2 times 6, 3 times 4. 3 and 4 would add together to be 7, so that wouldn't be it either. So it doesn't look like there's good. Let's see which solution they went with. Solve for the first variable. So they did the discriminant to figure out that it's a negative integer. So it's going to be 2 imaginary solutions, it says. Okay, so since they used the discriminant method just to check, the b squared minus 4ac, that's the method they're using. B squared minus 4ac. Checking the discriminant just to see if there's any solutions. Checking the discriminant.
We're going to start with solid argon. Argon is a gas found on the periodic
Oh,
table.
barely got that in there.
Explain how to make
All right.
argon change to
So b squared.
the gas state.
So using this equation, a is 1 because that's the coefficient of the x squared. B is negative 6 and C is 12. So B squared, negative 6 squared is 36 because negative 6 times negative 6 is a positive 36. Minus 4 times A, which is 1, times C, which is 12. So 36 minus 4 times 1 is 4. 4 times 12 is 48. So it equals negative 12. So if you remember when we looked at that back on page 1, when they talk about using the discriminant to check, where did they show the discriminant?
If I add a lot of heat.
Was at the top of this page. No. It was back here. I got to click the link. Discriminant. Got to click the link. If it's a negative, there are 2 complex solutions, which means imaginary solutions. That means that I is part of it. I is part of the answer, which means it's imaginary. It could be like 2 plus 3i, which means it's an imaginary number. So when we solve that, discriminant is a negative integer. So it'd be 2 complex numbers, 2 imaginary numbers. Every complex number has an imaginary part. So that means the system equation has no real solutions. So if we graph these two, to take a look at that, and it shows it on there, but we're going to graph it ourselves. The 2 original equations is y equals x squared minus 8x plus 12. That's the graph of the quadratic. And then the other one was y equals negative 2x. Well, there is no solution. They do not cross anywhere. There's nowhere that those graphs will ever touch. Look, as we zoom out, see that it just gets farther and farther apart. The closest part of where those graphs are is right here, but they never touch. So that confirms there's no solution. The discriminant said there's no solution because it was a negative answer. But we verified it by graphing it as well. So we're kind of combining the 2 lessons because remember the second lesson that we're looking at is graphing systems of nonlinear equations. So we're looking at the graph at the same time. So they show the same graph. There's no solution just because we checked the discriminant. So we wouldn't be able to factor that. Elimination.
Yeah. No, you got it.
You know, they do the same thing. It should come up with the same answer. You know, they get down to checking the discriminant again because when they did elimination, they end up with the same equation. The x squared minus 6x plus 12. That's the equation we came up with. And checking the discriminant of that equation, there's no solution.
Add there's number
All right, here's another one. They want 5 steps for elimination, 4 for substitution. Let's look at that one. I'm going to write this down too.
5.
X squared
Okay, that's okay.
minus
I'll post the recording
9x
hopefully by the end of today, okay?
plus 18. And look at this. This time we have 2 quadratic equations
Go ahead. No, you're good.
plus 2x minus 4.
Number 2, I want to start with the
So
gas.
in this
I want to
one,
make it liquid and then a solid.
we can substitute.
So
We can take either one of them and substitute into the other one and combine them. Or elimination might be easier because we can multiply by 1 by negative 1. So let's look at this one by elimination.
start to make them come back.
If we multiply this top equation by negative 1,
It seems like it's taken a little bit longer.
now we have negative y equals negative x squared plus 9x minus 18.
There we go.
We'll see if we get ourselves into trouble or can we solve this. Y minus y is 0.
Was it easier?
X squared minus x squared is 0. 9 plus 2 is 11x, 9x plus 2x, and minus 22.
When I add
Okay,
those, how fast
let's solve this for x. Add 22 to both sides.
Yeah, it's a little bit harder.
22 equals 11x, so x equals 2. That wasn't too bad with elimination. Let's substitute 2 back into either one of these equations. We'll do the second one.
That taking energy out process.
Y equals 2 squared plus 2 times 2 minus 4.
Your question number 2 was start with the
I
gas
just
minus
took
argon.
the 2 and I substituted it everywhere there was an x. So y equals 4 plus 4 minus 4. So there should be a solution at 2, 4. Because x equals 2, and when x equals 2, y equals 4. So let's graph these 2 quadratic equations and see if that's what it actually ends up with. If not, we might have done something wrong, which math is trial and error sometimes. 9x plus 18. Okay, this is one of our quadratic equations. Let's type in our other one. Y equals x squared plus 2x minus 4. Oh, look, there is one solution right there. That's the only place they cross. So when you look at it, they don't cross anywhere else. But they do have one solution right here. 2, 4. But did we get, when we did it mathematically? 2, 4. One solution. One solution. We did that one by elimination. We could have substituted. We could have taken either one of these. Like we could take this and substitute it in for y, or this and substitute it for that y. And then we would solve for x by combining the x squareds. But elimination seemed to be a little easier that time, just because they were lined up with easy to eliminate the y. Y equals y equals. Right? Times negative 1. The y goes away. It leaves us with just an x. And the x squareds canceled themselves out, which made it end up just being a linear. So that made it a lot simpler. All right. See what they got? 2, 4. They get the same answer. Solution 2, 4 right there. And that was by substitution. They should have the same answer down here for elimination. Yep, 2, 4. Here's more examples. If you need to see some other examples, they have more for you here. I won't go through these, but there's 2 more examples that they give. And you can try this on paper. If you're not sure, it's like, wait a minute, I'm not sure I'm getting this, Mr. Brock. It's kind of, yeah, this is different. So you should take these 2 equations, write those down. That's a quadratic and a linear. And try one of these methods. You don't have to do them both. If you know how to do one, you'd be fine. You can do them both just to make sure you know how. But try either substitution or elimination. This you can say there's y equals right there. So take that y and substitute that in, and you can solve that. And again, this will let you check your answer because it shows you all your work right here. And then here's another one. Try this one. Write that out on paper. See if you know how to do it. whichever method you did, you can check all your work. Did you do that? Did you do that? Did you do that? Is this your final answer? You know, so it'll give you great opportunities to figure out, do you understand before you actually have to count it as an assignment. So take advantage of these problems it puts in these lessons for you. All right, let's look here. Systems of equations with a rational equation. Means this has like a fraction, right? I said we can do any kind of thing. So solving it algebraically, if we have y equals x plus 1 divided by x minus 1, and we also have y equals x minus 1, they put the elimination first, or substitution. So with elimination, let's look at that. They multiply the bottom one by -1 because those y's go away. Right? The y's go away when you do that. So then you have to add -x plus 1 to a fraction. When you add that to a fraction, they're separate terms like that. The x plus 1 divided by x minus 1 minus x plus 1. So it looks scary, but once you multiply by the denominator, multiply by x minus 1, you can get rid of it and end up with this. Now, you might like the substitution better, maybe, but you're still going to end up with a fraction that you have to get rid of. So get rid of a fraction, you multiply by what's on bottom. In this case, you're going to multiply by x minus 1. See, they multiply by x minus 1 on both sides. So when you got x minus 1 times x minus 1, you end up with x squared minus 2x plus 1. Over here, when you multiply by x minus 1, it cancels out the denominator. So you end up with just what's on top, x plus 1. Here, let me write that one on paper just because some people may be a bit confused when you're dealing with that. Y equals x plus 1 over x minus 1 and y equals x minus 1. All right, we're going to work this one on paper just to kind of go through the step by step. So we're going to use substitution. If y equals that, then we're going to substitute that in for y. We're going to take that and put that in for y. So that means we have x minus 1, because that's what y equals x plus 1 over x minus 1. Okay, so anytime you have a fraction, if we had 2 equals 1/2 x, you know, let's say x over 2. Let's say x over 2. We got a fraction. If we want to get rid of the fraction, all we have to do is multiply by whatever's on bottom. 2 in this case. Multiply both by 2. 2 times 2 is 4. X divided by 2 times 2, those cancel each other out, so it's just x. And so 2 equals 4 divided by 2. We can see that. Works the same way with this. We just take whatever's on bottom and we multiply everything by that, x minus 1. So over here we have x minus 1 times x minus 1. And over here, these cancel out, which means we just have x plus 1. So we multiply these together. That's just distribution. You distribute the x to both of them and distribute the -1 to both of them. So x times x is x squared. X times -1 is -x, -1x, but that's just -x. -1 times x is -x. -1 times -1 is +1.
But if you're ever wondering, just look
and it still equals x plus 1. So this is x squared minus 2x plus 1 equals x plus 1. So if we subtract this to move it to the other side, minus x plus 1, which is minus x minus 1 when we distribute that. Subtract 1 and subtract x. Subtract 1, subtract x. We end up with x squared minus 3x. Oh, 1 minus 1 goes away, and this goes away. X squared minus 3x equals 0. Well, this factors real easily. This is just x times x minus 3. Just because it has an x in both terms, we can factor out the x. So that means x equals 0 is one of our solutions. X equals 0. And x minus 3 equals 0 is our other solution. So x equals 3. So that's our two solutions. This has two solutions.
Have a reading guide.
One when x is 0, one when x is 3. So if x equals 0, y equals 0 minus 1, y equals negative 1. So
Order section.
0, negative 1 is one of our solutions. X equals 3.
That on
Y
your-
equals 3 minus 1.
Okay, so make
Y
sure you're
equals
filling that
2.
in as you
3, 2 is one of our solutions. Two solutions for this one.
how many pages I've
0, negative 1, 3, 2. So let's graph both of these
Okay, so you're just gonna click through
and
those.
verify that we're correct. So let's go back to our graphing calculator here. Y equals,
Highlight it.
I got to put this in parentheses because I want both of those to be at the top, x minus 1. If I don't put in parentheses, it'll just put the 1 on top.
So we're gonna use this as our text.
So I'll show you. If I do y equals x plus 1 divided by, see, x minus 1. When I didn't put the parentheses, it didn't put the whole x plus 1 on top. I got to use the parentheses to make sure it's the same thing. Okay, so there's the first equation, x plus 1 divided by x minus 1. Here's the second one, y equals x minus 1. Oh, look, there's two solutions. See, that's the only place, as I zoom out, that's the only place we're going to touch. But they cross in two places. One of them is 3, 2, and the other one's 0, negative 1. What's the solutions we had? 3, 2, 0, negative 1. We proved it graphically that our math is correct. So when you graph that, you'll see that is the solution. So as they work through it, let's get to their final answer over here. X equals 0. There it is. 0, negative 1, and 3, 2. That's the two that we had as well. Okay, here's another one, just like the one above it. X minus 2, x plus 3. See, it's just like this one. So I'll leave that one that you can practice. And you can try that to see if you come up with an answer. Again, you can check your work. So gives you the opportunity to do that to see if you know what you're doing. Oh, system equations with a circle. Y squared plus x squared equals 20. Or y equals negative 2x. All right. We're going to do that one just because it's different. It's dealing with y squared in the equation. So if we say y squared plus x squared equals 20, y equals negative 2x. We have a linear equation and we have a circle. There could be 0 solutions. There could be 1 solution. There could be 2 solutions. Maybe that line doesn't go through the circle. Maybe that line just touches the circle right on the edge, or maybe it goes through the circle. So we should have 0, 1, or 2 solutions as our options here. So it looks like substitution would be the easiest thing to do because we have y equals. And since it equals this right here, we're going to put that in for y. So we have negative 2x squared. It's important to put that in parentheses because all of it is squared. It's not negative 2x squared. It's negative 2x squared, all of that. Plus x squared equals 20. Okay, this is our original two equations, remember? So negative 2x squared. What's negative 2x times negative 2x?
No, we're not in person. We're gonna have starting.
So we're multiplying those together. Negative 2 times negative 2 is 4. X times x is x squared. So negative 2x squared is 4x squared plus x squared equals 20. 4x squared plus another x squared, that's 1, right? So that gives us 5x squared equals 20. Divide both sides by 5. X squared equals 4. So if x squared equals 4, we take the square root of both sides. X equals, what's the square root of 4? It's 2 and negative 2. 2 and negative 2. Because negative 2 times negative 2 is 4. 2 times 2 is 4. There's 2 answers. So when x equals 2, y equals negative 2 times 2, because we're just substituting back into this equation. So y equals -4. So one of our solutions is 2, -4. So what about when the y is -2? Y
Yeah, are you
equals
coming, William?
-2 times
Excellent. Yes.
-2. Y is a +4. So our other solution is -2, +4. So let's graph these two equations. Check our work.
You did come. So you came
Okay,
to
let's
check
see.
it and you came to
Y squared plus x squared
we're downstairs.
equals 20.
That whole
That's the circle right there.
He'll be signing it for you.
Now the other one is just y equals -2x. It's just a linear equation. Ah, there it is. It does cross two places, 2, -4, and -2, 4. That's the two solutions that we had, -2, 4, and 2, -4.
And don't forget, we have advisory today, okay? At
So
1:25.
that is the two solutions
All right.
that we found
Rest for you guys to get questions.
algebraically, that now we proved it graphically.
And then you guys can take off if you're ready.
Right, there's our lesson summary.
All right.
Lesson summary, solving systems of nonlinear equations. You can use substitution, you can use elimination, just like we did with linear equations. The only difference is you're dealing with an x squared or something larger than just linear most of the time. Okay, they give you some extra problems over here to practice. Activity 1, activity 2 gives you x squared minus 7x plus 10 and 3x plus y equals 7. You can do it substitution, you can do it elimination, you can do it, and here's the graphing solution. All right, look, 10 problems there. And activity 1, there are 10 problems that you can practice. Do you have to do all 10? Not if you're getting it. If you do some of them and you're like, okay, I've got it, I'm getting the right answer every time. Well, there's no need to do all 10 of them, unless you want to look through and see if there's something different you haven't tried. Oh, there's 2 quadratic equations. Maybe I need to try that. So there's 10 problems. Then go to activity 2, and here's some that have fractions. And there's 3 of those you can practice. And again, if you're doing well with them, there's no need to do all the practice problems. It's just to help you know, do I understand? Do I know what's going on? Here's the assignment for the first one. 1, 2, 3, 4, 5 questions. Which systems are represented by the graph? So which quadratic equation and which linear equation is shown here? You can also work through those to see what the solutions are, to see if those are the 2 solutions. All right. Remember, you can always use Desmos. Always use Desmos to check your work or look at an equation to see what it is if you're struggling with anything. All right. The second one, we're not going to start spending time on because we've kind of covered it already. But I do want to talk about the assignment, because the assignment's a little different on this one. This one is graphing systems, which we've been doing while we were doing that lesson. This is graphing it right here, going to Desmos. So here's a video you can watch where she graphs it, 2 minutes, 8 seconds. They talk about solve this by graphing. All you have to do is graph those 2. Oh, first equation, second equation, find the point where they intersect, and those are the solutions. So we were doing that. Here's a hint. X squared plus y squared plus x squared equals r squared is a circle. So that's just telling you that that's a circle in the first one. So graphing those, you can go to Desmos, enter those equations in, make sure you got it right. If you see one like this, you can break it into 2 equations. Y equals -x squared plus x minus 3, and y equals -x minus 3. 2 different equations. See, they break it apart right there. Since they equal each other, you can just set them as 2 y equals. All right, so they give you some examples where they put those together. So just break it. This is one equation. This is one equation. Just graph them separately, and they'll show you solutions. This one's not even a whole number solutions. 4.43, 10.86. That's okay. Again, graph them separately. Let's look over here. Number 4. This gives you a word problem where you got to write the equation and then graph it. But again, you're just graphing equations. This talks about what kind of equations they are. If it's fx equals c, like a number, like fx equals 3, that's just the constant function. It's just a straight line at some number. Linear functions, it's quadratic if it's x squared, it's cubic if it's x to the third, it's radical if it's a square root. Absolute values, the straight up and down lines on both sides of that. And rationals have the x on the bottom. It'll have 1 over x in some way. All right, so there's some more examples that you can go through and look at on how to graph it and discuss the behavior. This is a piecewise function. Let's talk about a piecewise function real quick. All right, let me write this one down. Because piecewise is something we don't spend a lot of time on in algebra, so I'm sure you need a review of that. -1, x is less than or equal to 0, and x minus 1 when x is greater than 0. Okay, we're going to talk about this piecewise function. So this is a piecewise function. This one has 2 pieces. There's one piece that happens when x is less than or equal to 0. The other piece of the equation happens when x is greater than 0. 2 pieces. There can be more than 2. There can be 4 or 5, 6 pieces. They can put a lot of pieces. So first piece, second piece. So basically it's all based on the value of 0. So if we were graphing that, x is less than or equal to 0 means everything from here to the right. Oh, I'm sorry, to the left. Less than. So when x is less than, so that's like all this area over here. All right. And then x is greater than 0 is anytime the x is over here. So what does the graph look like? Well, let's take a look at that. In the yellow area, when x is less than or equal to 0, the graph equals -1. Always. So this is -1. So our graph just equals -1 forever. Anytime it's in the yellow area, when x is less than or equal to 0, all the way up to that line there, it's there. Now, what about when x is greater than 0? Anytime it's in the blue, it's x minus 1, which means it crosses at -1, but it has a slope of 1.
It's a little funky because the program didn't have like.
Because that is y equals x minus 1. That means the slope is 1 and the y-intercept is -1. So -1 is the y-intercept and has a slope of 1. All right, that's a B. B. So this is the graph of this piecewise function. You can combine piecewise function in any way you want to. Now, can we graph that on Desmos? Absolutely. Let me show you how to do that. Wait, here we go. All right. So the way we graph that is we say, okay, f of x equals 1. That's the first piece. I'm sorry, -1, -1, -1. And the way we tell it is we say x is less than or equal to 0. Use those squigglies, see those squiggly lines? And we tell it only graph when x is less than or equal to 0 for this equation. So see, it stops right there at 0. But it's -1 everywhere, forever. So now we want to say f of x equals, and we give it the other piece, x minus 1. But again, let's use the squigglies and say this is only when x is greater than 0. Yes, Bethany.
Just so I know how to graph, how do I do like the greater than or equal to on the keyboard?
Okay, good question. So if I want to say y equals x squared, but I want it to only be when x is, greater than 2 or something. when I hit the squiggly, excuse me, X, if I hit greater than, which is above the period, I think, and then I hit equals, greater than, and then I hit equals, it combines them. See it put the little line underneath it? I hit two different keys, but it knows what I mean. Oh, you mean greater than or equal, same thing of 2, or whatever I wanted to put in there. And I think I can do it in either order. If I say equals or greater than, oh, does it still do that? No, it doesn't do it that way. You got to do the greater than or less than first. It didn't understand when I did equals first.
All right. Thank you.
So yeah, just do greater than and then hit equals and it'll combine those.
Perfect.
Good question though. So we know how to do that on Desmos. But yeah, you can graph piecewise just by restricting. This is restricting the domain, really. We said I only want when X is greater than 0. That's where I'm restricting the domain. I don't care about any X's that are not greater than 0. So only graph this equation when X is greater than 0. So that's important to know how to do. So you can graph a piecewise function, because if we don't put those restrictions on there, it's not a piecewise function. It's two different functions. Now we got crossing lines. That's the whole thing. So we need to restrict those. So this is a piecewise function. All right. Lesson summary right there. Talks about graphing solutions and how you can represent it. Okay. I want to look at the assignment. There's another practice problem over here. This assignment's different. This is something you got to do and turn in. Okay, it says graph those and check your work. Yeah, so this is their practice problem. They give you 6 practice problems. Okay, if you look at the top of the page, it says for the assignment on page 6, choose option 1, work alone, because I'm not going to put you in groups. That's the other option. Since we're all in our own homes, we don't want to be in groups. Let's go to the assignment. See, there's 2 options down here. Work alone or work collaborative. This is the work alone option. This is your assignment for the second, the 1.04. All right. After a dreary day of rain, the sun peeks through the clouds and a rainbow forms. And you notice the rainbow is in the shape of a parabola. And here's the equation for this rainbow. Negative x squared plus 36. All right. In the distance, an airplane is taking off. And as it ascends during takeoff, it will make a slanted line that cuts through the rainbow somewhere, right? Because it's going to make a straight line and going to cut through the rainbow at 2 different points. So you need to, here's part 1, create a table of at least 4 values and include 2 points of intersection, 2 points where it's going to cross through this rainbow, right? Pick 2 points. And if you want to graph this on Desmos so you can play with this, you can. You can put y equals negative x squared plus 36. Y equals negative x squared plus 36. So you can have those on Desmos and find some points you like. Oh, 420 is a point. There you go. You can find some points where the airplane goes through there, but it may not be exact points. Oh, does it go to an exact point there? 232 is a point. So you go 232 and negative 420 or something like that. Have your plane going through there. But 4 values for a function. So if you're choosing a function, it should be a linear function, right? If I'm going to choose the point negative 420, and then I'm going to choose the point, what did I say this was? 232. Yeah, 232. Oh, 232. Okay, that means that's a pretty steep takeoff. That plane is going up really fast. My other 2 points have to be in line with that. I would have to put a point down here somewhere. I'd have to find the line that goes through both of those. And I'd have to put a point at, I don't know, let's see, negative 60 in line with that. Nope, negative 60 is not going to be in line. I got to find 2 more points that make a line. That's not going to be a linear line either. I might need to write the equation of that line.
There we go. That's a lot.
But anyway, you need 4 points of a function that has at least 2 points of intersection. Maybe you'll just write a line first. That's another suggestion. Maybe I'm going to say, okay, well, I'm going to do a line of y equals x plus 20. So I know I've got a line that goes through there. Maybe I'll just write the equation first and then pick 4 points. And my point may be something funny like that. Maybe. And then maybe I'll pick this point, negative 10, 10, this point, and maybe this point. But I got to have 4 points on my table. 4 points. Then step number 2, analyze the 2. Answer these questions about the 2. What is the domain and range of the rainbow? Right? What's the possible x's, possible y's for that equation? Do all of the values make sense in this situation? If you say the domain is from negative infinity to positive infinity, does that make sense? What are the x and y intercepts of the rainbow? You can go to Desmos, like I said, and check that out. What is that point? What is that point? What is that point? It'll give it to you on Desmos. What do those represent? If that was really a rainbow, what do those points represent? Is the linear function you created a positive or negative? Well, it may depend on how you did it. If you made your plane taking off the other direction, that would be a negative going left to right, but most of us are going to take off this direction. So that would be an increasing, right? Explain. What are the solutions or solution to the system's equations? What's the solutions? If you have them crossing, hint, there's one solution. What does that represent? What does that mean? If you got an airplane taking off in a rainbow, what does that point there mean? And then here's the last one. This is where I said it's important to know how to do it. Create your own piecewise function. Okay, that has nothing to do with the rainbow. This is a totally different problem. Number 3 has nothing to do with the rainbow above. Create your own piecewise function with at least 2 functions. You can make more than 2 functions if you want to. And explain, use a complete sentence, the steps for graphing. How do you graph that? And you can graph it with Desmos if you want, or graph it by hand, but submit a graph. Do a screenshot. After you graph it, do a screenshot and include that. Okay, so that's what you're doing. First, you have this rainbow, and you got to create a table. So the first thing you do is create a table of 4 points for a line. And like I said, if you want to create the line first and then make 4 points from that line, that may be easier. Then you're going to answer these 4 questions, and then you're going to create a piecewise function. Now, let me show you where you turn that in. Right here. You can do it on a Google Doc. That's probably the easiest thing to do is just open up a Google Doc, paste your information there, answer your questions on the Google Doc, put your screenshot of your graph there, and then you can submit it. You can attach a Google file right there. It'll let you choose. Oh, pick one. Choose Google file. Then it'll take you where you can go find your Google Doc. So that's probably the easiest thing to do is just make a Google Doc. The other thing you'd have to do is you'd have to type everything in here, paste your picture in here. That may be trickier. At least in your Google Doc, you got ways to manipulate it easier than working in this. Okay, here's the rubric. Okay, how's your mathematical reasoning? How'd you do? Did you answer all the questions? 35 points if you answered all the questions with all the work that goes with it. And then was everything correct? You get 5 more points if it's all correct. 35 points means you answered everything. Maybe you had something a little off, so you didn't have it all correct. Maybe most of it was correct. You got 4 points for everything being correct. But you did answer everything, so you didn't leave anything off. You did your piecewise function. You answered those 4 questions. You did your table. All right. So you can get all the points just for doing all the work. Even if you're wrong about something, you can get 35 out of 40 just by making sure you include everything. And if you get everything right, you get that last 5 points. So there's your rubric for it. That's what we have this week. 1.03, 1.04. Solving systems and then graphing systems. And remember, you can always use Desmos to check your work. If you do a problem here and you did it algebraically and figured out the answer, you say, I think the answer is this one. I'm going to go graph it on Desmos just to double check myself. Yes, I'm right. Don't forget you have Desmos as a tool anytime. You also have all your notes as a tool anytime in this class. So All right. Well, class was 10 minutes longer because we had a fire drill, but not too bad. Tonight is parent-teacher conferences. If anyone's coming up with their folks or their folks coming without them, we're here till 8 o'clock tonight. The virtual school is located at BHS. So we're in the BHS building. You'll see a big sign on the building that says virtual up there. So you come in that door if you're coming tonight. And otherwise, have a great week. It is a B day. When your grade check, your grade should be in hack. So you need to be here. I'll see you Thursday and Friday.